Hello everyone, this is Group Gamma and our group will be presenting about integration of vector functions. So in this video, our learning outcomes is to find the arc length and also the motion along a curve. And what is arc length? Arc length refers to the length of an arc L on an interval AB. And to calculate the arc length on an interval AB, we need to follow three steps. With the given vector functions RT, the step 1 is we need to differentiate the function first. And step 2, we need to find the magnitude of the differentiate function, which we follow the formula square root the sum of the differentiate function. And the step 3, which is the final step, we need to integrate the magnitude obtained from step 2 with interval AB. Now, let us look at the first example, example 1, which is find the arc length of RT, cos t, sin t, and t for the interval 0 to 2 pi. To get the answer of this question, we need to just follow the three steps that I have explained before, which is step 1, we differentiate the function first. We differentiate RT equals to cos t, sin t, and t, and we get it is negative sin t, cos t, and 1. And step 2, we need to find the magnitude, which is we square root the sum of the differentiate function, and the answer is 2. Step 3, which is the final step to find the answer of this example, which is we need to integrate the magnitude and we need to insert the intervals into this function, which is 0 to 2 pi into the equation, and we get the final answer, which is 2 pi sub 2.
Now we are going to discuss about arc length parameter with base point. The arc length of r tau from t0 to t is calculated by using formula L equals the integral from t0 to t of the magnitude of r prime tau d tau. We are using tau in this subtopic is just to prevent the variable conflict with the t at the upper boundary. And the steps is almost same with the normal arc length, which is differentiate the r tau function, then calculate its magnitude and do integrate with substitute the boundaries. Which the difference is we need to calculate the t0 in this subtopic. To find t0, we have to let rt equals to the base point and compare both components. By referring this example, find the arc length of rt equals to 3t, t squared, and 4 power of t from 314. By comparing I, 3t equals to 3, then t equals to 1. By comparing j, t squared equals to 1 and t equals to 1. By comparing k, 4 power of t equals to 4, then t equals to 1. Since 3 of them shows that t equals to 1, therefore t0 equals to 1. After obtain t0, sub it into the formula, and if the formula didn't give information for t, the final equation of LT will be in terms of t.
So on to the next part, which is example 2. The question given is find the arc length function of RT as the given function are 3 sin t, 4t, 3 cos t from point 003. And then we will move to the next step, which is we need to find the t0. How do we do so? So we can do so. First we need to do is by comparing the I, j and k. The I will refers to the first term, and then the j will refers to the second term, and then the k will refers to the third term. And then we just need to compare the first term to the first point as shown as the solution given. 3 sin t is equals to 0, so we get t is equals to 0. By comparing j, 4t is equals to 0, and then we get t is equals to 0. And lastly, by comparing k, 3 cos t is equals to 3, and then we will get t is equals to 0. So it is proven that all of the t for each term are the same, so that we can conclude that t0 is equals to 0. And then after finding the t0, we can now differentiate the function. As we get 3 sin t, we will get 3 cos t. 4t, we will get 4. Differentiate 3 cos t, we will get negative 3 sin t. After that, we just need to find the magnitude as shown as the solution given. and then the magnitude we will get for the function is 5. So on to the next part is that we just need to integrate the function as we get the t-naught earlier before, which is 0. We just need to substitute the value, and then the final answer for the LT is equals to 5t. So here's the extra example. In case if they give us the value of t, then we need to substitute the value of t into the function. For example, as shown given, LT is equals to 5t, and then we just need to substitute the value of t into 2, and then the final answer we will get is 10.
So first you can see in the slide there is a two-dimensional 2D which is underlined clearly. So the motion vector is, the formula is given there. So the speed is equals to v in bracket t. So if you want to see, first you want to, if the in the question given position, so we must use to find a velocity or acceleration. If we should differentiate, if they give acceleration in the question, we need to find the velocity or position, we need to integrate. So in this thing, in this slide or in this thing, we are mainly focused on integrate. So let's go to this next slide. So as you can see, there is two-dimensional and three-dimensional. Two-dimensional, which is x and y. If three-dimensional, there will be z. So let's go to the next slide. So the motion along a curve and in space. So in curve we will have only x and y, but in space we will have three, which is x, y and z. So the summarized formulas for position vector: integrate v, which is velocity, and for velocity vector we should integrate acceleration. For speed we must use v and t. So for acceleration is at, which is acceleration. So for the example, integrate 1, 2t and 3t equals 3t squared. So the outcome have constant because the integration don't have boundaries.
Now, let's hop into the example of motion along a curve and in space. The question states a particle moves along a curve in space and its acceleration and time is given by 6t, 4 and 2 cos t. And we have to find the velocity vector if v0 is equal to 103 and the speed at 5 seconds, and the position vector if r3 is equal to 50i plus 17j plus 4k. So for the first one, to calculate the velocity vector, we have to integrate the acceleration vector first. After the integration, we will get 3t squared plus c1, 4t plus c2, and 2 sine t plus c3. Then sub 0 into each t, and we will get c1, c2, and c3. Then we have to compare the constants with the 1, 0, and 3. Then we have to rewrite the full velocity vector. Then the final answer is 3t squared plus 1, 4t, and 2 sine t plus 3. So for the next, the speed at 5 seconds. So we have to sub 5 into each t in the velocity vector. And we will get 76, 20, and 1.0x2. To find the speed, we have to find the magnitude of the velocity vector. So to do this, we have to square each of the number in the velocity vector and then square root all of them. And the final answer will be 78.59. So for the last question, it needs us to find the position vector if r3 is equal to 50i plus 17j plus 4k. So we have to integrate the velocity vector first, and then we have to sub 3 into each t in the position vector. And we will get 30 plus d1, 18 plus d2, and 10.9x plus d3. Then we have to compare each of the I, j, and k. So we will get d1 equals to 20, d2 equals to -1, and d3 equals to -6.98. Then we have to rewrite the full position vector. The final answer will be t cubed plus t plus 20, 2t squared minus 1, -2 cos t plus 3t minus 6.98. That's all for our group's topic. Thanks for watching.